Hello students, this is our introduction to stoichiometry. I just wanted to let you guys know that things are going to get a little bit challenging this section, but I want to just give you some encouragement. You all can do it. I have no doubt about that. You've shown great resiliency, and I just look forward to seeing the work that's done from everybody. Stoichiometry is kind of a way to predict quantitative numbers in a chemical reaction. So, for example, if I want to know how much product is going to be made by combining two reactants, I can do that mathematically on paper and then move into a lab setting to figure out that information in the actual setting. So, um, that's just one application of stoichiometry. But if you take a look at what we have in front of you, double roadmap, this looks very similar to our single roadmap, only we're combining it with a mole ratio. We've done a little bit of mole ratio earlier this year, but we're going to kind of bring it all together. So there's a couple different starting points that we can be in, and you should reference this chart when you're completing problems. I've also put a simplified version of this chart in the folder as well, so take a look at whichever one helps you out. But we could potentially start with a volume. We could potentially start with a mass. And notice that volume would progress to mass should that situation come up. We could start with a mole value, or we could start with a particle. And if you remember, those particles are atoms, ions, molecules, or formula units. And it just kind of depends on which one it is that you're looking at. You've got Avogadro's number there as a reminder. Your mole ratio, we're going to be using balanced chemical equations now. And so your mole ratio are going to come from coefficients from those balanced chemical equations. I think I spelled that wrong in there. Forgive me for that. And then after that balanced chemical equation, coefficient mole ratio, that is kind of the key that will get you to the next step. And then, of course, we would come out in mass using molar mass. We could come out in density again as a volume or another particle, depending on just what the problem is asking. If you notice here, look at where each of these goes. They both go to moles. So the first thing that you're going to want to do is to convert to moles. That's kind of like the step one. Now, you're going to have to ask your teacher specifically how you want to have these done. There's multiple different ways to complete a stoichiometry problem. And as long as your logic makes sense and you get that final answer correct, like I said, there's no wrong way to do it. A lot of it comes down to dimensional analysis and following your units. And then so step two, use that mole ratio step there in the middle. And then step three is to convert to your final units, whether that be grams or particles. And so I teach it in a step one, step two, step three format. I know maybe some of your other chemistry teachers will really stick to the roadmap. And as I mentioned before, it really is up to the teacher on how they want to have that done. Okay, and we are on to the next section here. So what is stoichiometry? Let's break that down a little bit more and take a look. Stoichiometry is the use of a balanced chemical equation to determine the amount of a reactant needed or product produced. So we can kind of move things in different directions. Always start by writing a balanced chemical equation from the reaction given. Identify the givens and unknowns inside the problem. Use your double roadmap or reference document in order to help you get to that final answer. Make sure you can correctly identify the coefficients from the balanced chemical equation. This becomes your mole ratio. So very, very important. scientific notation, significant figures and labels in your final answer as well. So again, you can pause and go back. Some of these problems do get a little lengthy, and I will be skipping through the calculation of molar mass. So if you are still struggling with the molar mass, please, please, please reach out to your teacher. That's something that you need to be able to know. They'll probably get you a video from YouTube in order to get that information to you quickly. So let's take a look at our first sample problem here. First thing always is to have a balanced chemical equation. So what mass of Al can be produced by the decomposition of Al2O3? Now, what you're probably really excited about is that we're going to be bringing in that predicting products and balancing chemical equations. So I know you're super happy about that. Al2O3 is a binary compound, meaning there's only two different elements that make up that compound, aluminum and oxygen. And so as we break out a binary compound, we take those two elements and split them apart. So oxygen being a diatomic, and then as we come in and we balance, there's 2 aluminum on the left, so let's make it 2 on the right. If we then take a look at our oxygen, we've got 3 and 2, so that's a scenario where the smallest number they can turn into is a 6, so we put our 3 here and our 2 here, which forces us to come back to the aluminum and change that to a 4. So that's kind of how I look at it. I know my students know the classic 3-2 scenario. That's something we talk about. The smallest number, 3 and 2, is 6. So if you see that 3 oxygen, 2 oxygen, you know you need to take them both to 6. So let's go ahead and set up our work following our double roadmap or reference document. So we'll take our given over 1. That's the first thing that we want to do. So 12.4 grams of the Al2O3 over 1. We're asking for what mass of aluminum. So we know that we're looking for a grams of aluminum given 12.4 grams of the aluminum oxide. So our double roadmap or reference document tells us that we need to convert to moles first. So what we're going to have on the bottom is going to be the molar mass of our given compound, 101.96 based off of our periodic table, with 1 mole on top. Notice grams cancel, so we're back into that dimensional analysis where we are canceling units. Next is that mole ratio. On the bottom, you always write in the coefficient of the given, Al2O3. It's the thing that we're trying to cancel out, is going to go on the bottom. And then the ratio of 1 mole of Al on top. Now you'll notice your 4 over 2. If you want to reduce that down, you can. I would strongly encourage you to leave it as is. That's okay for stoichiometry to have a non-reduced fraction in the middle. It's just easier to see that mole ratio. And then if you notice, we are now in moles of our product. And according to our double roadmap or reference document, we need to cancel moles one more time to get into that final answer unit, which is grams. And anytime we see grams or mass, we know we need to reference the periodic table. So there you have it. All those units cancel out. We're asked to find what mass of Al, which is grams. And when we multiply all the way across the top, multiply all the way across the bottom, and then divide, you'll end up with the correct final answer, 6.56 sig figs, of course, times 10 to 0 grams of aluminum produced. Now, what we would find that when we go back into the lab setting, we'll get an actual reading of that. So that's something that you can keep in mind. So as we move into a couple student examples, it's very important that you get that balanced chemical equation. We kept the chemical equation the same. Okay, but notice that we are bringing volume into the equation. And we're bringing volume into the equation. So when you get to your final conversion, where you'll have grams over the 1 mole, you're going to have one more. and you're given a density here, and density is always going to have 1 liter on top and then whatever that mass reading is on the bottom. So that's a little bit of help for you. Again, that reference document that I've posted into the same folder as these video notes has a section where you can say, okay, I'm solving for density, I need to go here, or I'm solving for volume using density, I need to follow this column. So please look at both the double roadmap at the beginning of these notes and that reference document as well. It may be helpful to you. Big thing, you want to cancel out units all the time. Cancel out units all the time. All right. So another quick example here. I'm going to work through this one quickly, but I think it's probably worthwhile to see just another one here. How many grams of ammonia are produced? So if it says are produced, we know that that means the NH3 is going to be on the other side. When we have 4.37 milliliters of hydrogen gas, so it's hydrogen, so that's a diatomic, so H2, and nitrogen also H2, also diatomic. You'll see the 3-2 scenario, so 3 and 3, and that balances out my nitrogen. I'm given that 4.37 milliliters of hydrogen gas, and I'm asked for grams here. I'm not going to work out this problem in its entirety, but I do want you to see that our given now is volume. But the mentality does not change. We need to get ourselves to moles. If you follow your double roadmap, you'll see that you'll need to use density in order to do that, and we are given a density. Milliliters, so 1 milliliter on the bottom, 8.99 times 10 to the negative 5th grams on top. Units cancel. Now we can move into that little bit more comfort range where we end up with getting ourselves to mole. And that's the mass from the periodic table. And then here's where you'll have that mole ratio step. And then you can solve for that final answer as well. So again, please keep referencing that double roadmap. You will have that on your assessments. You will have that for all of your homeworks. So that's definitely something that you should continue to work on. Please move now into the stoichiometry assignment. I do want to help you balance that first equation because it can be kind of challenging. Balancing is still going to be something that is very important for you moving forward. But obviously, if you are stuck on a particular problem, use your resources to help you with balancing if you need to. You'll see that with the sodium carbonate as the reactant and the product, sodium phosphate, we've got that 3-2 scenario. So I love picking these out and starting there. I know that I'm going to need to get to 6. That's the only way we can balance out 3 and 2. I'm going to take a look now at, and I just kind of pick through and I move through logically here. Look at my phosphorus. I have 2 phosphorus, so I need to place a 2 out in front here to balance out the phosphorus. I'm going to take a look at my carbon. There's 3, so I'm going to place my 3 out in front of here. And then as I look through, I only see hydrogen in 2 places. There's hydrogen here and hydrogen here. And so 6. So I know I'm going to need 6 on this side. If I go through then and I count my oxygen, on the reactant side, we have 8 plus 9. So that is 17. On the product side, we have 8 plus 3, that's 11, plus another 6, and that's 17, so that's a balanced equation. So use this equation in the first stoichiometry assignment. Please ask questions as you need to, but I think if you are following that double roadmap, you're following the reference document, you should be good to go. Please reach out to your specific teacher if you have any questions. Please pause and rewatch this video as needed.